Now, after sequencing has happened, we have to estimate the duration of the project. We have to estimate the duration of the project. Now, project duration generally calculated in the working days, and elapsed time is actually the calendar time. A duration is generally working days. Suppose my project is 50 days. 50 days means 50 working days. But elapsed time could be 60 days. Because elapsed time means duration plus non-working days. That is elapsed time, calendar time. So I will take you through some duration estimate the things, because duration estimate are, in my opinion, are a bit important. Just give me a moment. So look at this. The duration estimate, what happens? There are a couple of methods which we use for duration estimate. I will just explain this. One is expert judgment. That is WBS estimate. You have created WBS, and every item, against every item, you are saying it will take 10 days, it will take 5 days. It's the most common method, right? But most inaccurate method. Most common, but most inaccurate. You give to 10 people, they will give you 10 different estimates. And maybe varying a lot also. It largely depends upon the experience of the person. And therefore, it's called the expert judgment. Second is analogous. Analogous could be better than simply expert judgment. But generally, even expert judgment have some kind of analogous estimate. What is analogous estimate? One-to-one comparison. One-to-one comparison. There is a project A has happened in past. I have another project B which I am going to do, and they are quite similar. So what happened in A as actual, I will use to estimate the B. It may not be same, but I will use as a base to estimate for B. For example, in A, some activity took 10 days. Similar activities there in the B also. But I know that A has specific conditions. It took 10 days, but I think it will not take 10 days in our project. Maybe 8 days are good. So I put 8 days. But the base of 8 days is again 10 days done in the A. So this is called analogous estimate. Analogous estimate means my project is similar to some other project, and actually what happened in that project, I'm using that as guidelines for me to estimate for the project which I'm doing now. Okay. Now comparing to the expert judgment, they may be a little better because they have some base behind that. Expert judgment is also have some base. There is some intuition developed with the experience kind of thing. So it's not as bad, but they may not be as accurate because the conditions of B can be very different than condition of A. And therefore, this project may go in different way despite being similar. Despite being similar. Right? Now, so accuracy will not be very high because one project does not represent the organization. One project does not represent the organization. Therefore, with one project, I cannot say that this project will also go the same. So the accuracy will remain less. Third is parametric estimate. What is parametric estimate? Are normally very calculative in nature. For example, we did the pillars, we put the slab, we also did the brickwork, we also did the plaster. Now the time is to paint it. Now the time is to paint it. You called the painter and asked, tell me how much time it will take. So what he will do? He will first measure the surface area, right? He will first measure the surface area. Then what he will say, total surface area is 100 square feet. My one resource generally paint 5 square feet in a day. That means one resource will take 20 days and I'm going to deploy 4 people. So I think in 5 days it will be completed. So you will come back to say, okay, it will be completed in 5 days. You see, this is called parametric estimate. Now there are a couple of things. One is they are based on formula, calculation based. Second is one figure about, he says his one typical resource takes 5 square foot per day. Paint 5 square foot per day. From where it has come? From his experience of previous projects. Right? So what we do in this, like here, the productivity of one labor. How we assess? We use a regression analysis, the statistical tool, regression analysis. In this, what we do, in analogous, we study only one project. In the parametric, we study many projects, one after another. So suppose we did 50 projects last year. So I study all 50 projects. 1, 2, 3, 4, 5, 6, 50. Right? Then I measure all my parameters in all 50 projects. And with this measurements, I derive a formula, fx is equal to y. So in terms of y, I have got fx. So if I know y, I can get x. Sorry, if I know x, I will get y. So somewhat like a y is equal to maybe x square plus x plus 13 or something like that. So how it happens? This is a simple formula, but what happens? We do like this. This is, let's say, one parameter here, one parameter here. So like x, like y. You x and y, you calculated it all 50. You measure x and y because they are all happened, right? I know the value of x and y in all the projects. So I measured x and y from all 50 projects and start plotting here. I plotted all 50 here. Some will be very weird also. We normally in the statistics, we miss them. We reject them. So what happens? I look at the trend. What is trend? Trend shows like this. Trend is showing like this. So if X is size of the project and Y is the productivity, what it's saying, as the size of the project increasing, the productivity is going down. But I have the productivity. Either you can take this as a productivity like 5 square feet per day, or you can segmentize it to be more accurate. If your project in this area, take this. If in this area, take this as a productivity. In this area, take this as a productivity. So you get the productivity from where? From by study of 50 or 60, 100 projects. Now 50, 60, 100 projects actually represent the characteristic of organization, right? Actual behavior of the organization. So the way 50, 60 project has gone, the same way my project will also go. And therefore, these estimates will be much more accurate comparing to the analogous and the WBS expert judgments. Got it? So parametric estimates are calculated. They are based on study of many projects, not one project. And then deriving a formula and calculating, using that formula to calculate the estimate of or estimate the new project. Another method is called 3-point estimates. 3-point estimates are generally used when there is a risk in the project. There's an uncertainty in the project. Something like R&D project. I'm not sure outcome will be favorable or not. It may take more time. So what happens here? I do not estimate one figure. I estimate 3 figures: optimistic, most likely, and pessimistic. For example, for an activity A, the optimistic, most likely, and pessimistic, I will say generally take 10 days. Okay, but there is a risk in A or multiple risk in A. But you said, okay, consider that all the risk in A, consider that all will materialize. Whatever can go wrong will go wrong. Consider that. Then tell me how much time it will take. I will say then it will take 20 days. Well, now consider, that is pessimistic, right? Everything can go wrong. Then how much time it will take? 20 days. Now look at the another side, that nothing will go wrong. Everything will be fine. Whatever we have think of may be possible, but it will not happen. Then how much time it will take if nothing goes wrong? Let's say, I will say it will take 6 days. Then I will calculate this formula. 6 plus 4 into 10 plus 20. So it becomes 66 divided by 6. Why 6? Because 1 is this, 2 is this, and 4 into m. The 4 points are m. So what we are doing, we are concentrating on m. We are giving more weightage to m. We also call weighted area, weighted average, because we have given more emphasis on m. Why? Because if we do not give more emphasis on m, the P and O could be very deviated and they influence a lot the middle part. So in reduce the influence of P and O, we have given more weight to m. So total point becomes 6. I divide by 6, it will become 11. So what I expected, that it will be complete in 11 days, but that may not be sufficient because it may not complete in 11 days. So I calculate the standard deviation also. The higher limit minus lower limit divided by number of points. So higher limit is 20, lower limit is 6, and divided by 6. How much is that? It has become 14, 6 to the 12. Let's say approximately 2. It is 2 point something, but let's say approximately 2 for simplicity. So then what is this? That means the activity A will complete 11 plus minus 2 days. That is the standard deviation. So it will complete somewhat between 9 to 13 days. So what I'm saying that, okay, the mean time is 11 days, but this activity may finish somewhat between, if everything goes fine, it will complete in 9 days. If things may not be favorable, then it will take 13 days. This is a much better forecast than just giving a fixed number. We do this when we have a risk in the project or more risk in the project. many long-term projects, many which are expected to be marred with some of the uncertainties because of the outcome, because of the political scenario, because of the many other things. This is called 3-point estimate. We also called simple average, that is this, but this is less used because P and O greatly influence the middle actually. So it may be tubed also sometimes. Right? So let's come back here. So we discussed about expert judgment, analogous, that is one-to-one, parametric, that is studying many projects and then creating a formula, driving a equation, and then calculating our estimates, and the PERT estimates.